Você nos avisa quando estivermos online. Bem, então, boa tarde a todos. Good afternoon. We are starting this qualification exam for the PhD candidate Omid Orang. The title of the work is High Order Fuzzy Cognitive Maps and Deep Randomized Networks for Time Series and Nonlinear Dynamical Systems. I would like to thank the marketing professionals in our Minds lab, which are keen to develop fancy titles for thesis. I would like also to thank all the members of this committee. We have the privilege to have high-level professors and colleagues in this committee, so it's a great pleasure for us. Thanks for accepting this invitation. The committee is composed by me and Professor Petrônio Silva as advisors of the work, Professor Fernando Gomide from the University of Campinas, Professor Guilherme Barreto from the Federal University of Ceará, Professor Hugo Siqueira from the Technology University of Paraná, and Professor Rodrigo Silva from the Federal University of Ouro Preto. Omid, presentation, you have 50 minutes to present your work. After your presentation, we proceed to the questions and comments from the committee. Okay?
Okay.
So the floor is yours. Feel free to begin whenever you're ready.
Okay. Let me please.
While you're sharing your screen, I will take this time to thank the audiovisual sector of our School of Engineering, which is allowing us to broadcast this presentation and qualification exam live on YouTube, in the channel of the School of Engineering. And after this broadcast, the recording of this session will be available in the channel of the School of Engineering and also in the channel of Minds Lab on YouTube.
Okay. Thank you, Fred, for introducing me, and hello, committee members. Can you hear me clearly, and can you see clear?
Yeah, fine. Yes, it's loud and clear.
Yes. Okay, let's go. Hi, everyone. Welcome to my presentation. My name is Omid Orang. I am a PhD candidate at Machine Intelligence and Data Science Laboratory, Electrical Engineering Department, Federal University of Minas Gerais. Now I am going to present my qualification exam, which is titled as High Order Fuzzy Cognitive Maps and Deep Randomized Networks for Time Series and Nonlinear Dynamical System under the supervision of Professor Frederico Guimarães and Petrônio Silva. Before diving into our model, firstly, we need to have some basic knowledge over fuzzy time series, fuzzy cognitive maps, and reservoir computing. So firstly, we have some introduction over some fundamentals over these concepts. Then we introduce the methods and discuss over the results. And finally, we have conclusion and some possibilities of the future works. Time series defined on life as a set of time order observation of phenomena over successive period of time. For instance, energy consumption, whether data is stock price, or even your heart rate are measured in time series. So time series forecasting and analyzing is an active and open problem that attracts the attention of many scientists in many applications to make better decisions across some, especially with the advent of some recent technologies nowadays, including IoT, IoE, or big data, by gathering lots of data along the time. The task of time series forecasting is to predict the future values of phenomena by using historical data. So different types of method introduced in the literature. Since traditional time series forecasting suffers some limitation, including time-consuming, complexity, lack of scalability, and explainability, inability to deal with some uncertainty and some complex problem in the real world, some new soft computing techniques introduced that had attracted the attention of many machine learning scientists. For instance, fuzzy time series forecasting methods are used wisely in many applications according to the literature, according to their interesting features such as simplicity, explainability, flexibility, updatability, readability, and high accuracy level of forecasting. What is fuzzy time series? Fuzzy time series was introduced by Sang and Shisem in 1993. But since this method is complex due to the complex computation due to the max-min operation, in 1993, a simple method proposed by Chen in the literature that used widely. In contrast to classical set, fuzzy set defines partial membership by dividing universe of discourse into some partitions in order to explain uncertainty, increased value. It means that any member in our increased value is defined according to the blindness to each fuzzy set. So we have a fuzzy set which is defined according to this equation by considering some number of elements, for instance, U1, U2 until UN, and also by considering the membership degree, which is presented by mu A UI in this equation. And it also can be shown by this summation notation, as you can see here. So mu A is the membership function of fuzzy set, which is used to map a universe of discourse to a into interval 0 and 1. And as we discussed, mu A UI is membership degree of each member to a fuzzy set A. So fuzzy time series is a sequence of fuzzified value over our numerical data or crisp value on which some fuzzy set defined over our universe of discourse. Any method in the literature that used for fuzzy time series forecasting follow this structure, which composed of defining universe of discourse, partitioning, fuzzification, extracting fuzzy logical relation and fuzzy logical relation group, and finally defuzzification. Each study in the literature focused on each step to improve the accuracy, so different types of method introduced by focusing on each step to improve the accuracy. So, in detail, in training process, the crisp data is partitioned to generate our fuzzified or linguistic variable. Then the fuzzification process is exploited to generate the fuzzified value, and after that, the knowledge extraction step is used to generate our knowledge-based model. After defining the model, the new crisp data in our forecasting process is used, and after fuzzification, the inference step is applied to generate right-hand side in the rule, and finally, the defuzzification process is used to predict the final predicted value. Now we're going to introduce each step. Firstly, universe of discourse. The goal of universe of discourse is to generate linguistic variable by dividing the universe of discourse partitioning. The goal is to generate linguistic variable by dividing universe of discourse into some overlapping interval by considering some important parameters such as partitioning number, for example, which should be selected optimally because increasing the number of partitions or fuzzy set make the model more complex and the possibility of overfitting is increased. And when we decrease the number of partition, or for the lower number of partition, the possibility of underfitting is increased and because of the simplicity of the model. Membership function that measure the membership value of each element to the universe of discourse to a fuzzy set, triangular, trapezoidal, or Gaussian, for instance, are the most common methods. However, other methods, including type 2 fuzzy set, hesitant, and non-stationary fuzzy set, also introduced in the literature. Partitioning method is the other important parameters, which is divided into equal and unequal size, with the same size of partition used in the, for instance, such as grid partitioning, which is easy to implement and not time consuming, but in contrast, unequal size have good accuracy, but sometimes they are time consuming. This unequal size divided into mathematical and soft computing approach, where the soft computing also consider clustering and meta heuristic, as you can see in the table. The simple example of partitioning method, as you can see in this figure, using triangular membership function and different types of partition number, and also by considering different number of partition according to the figure. The goal of falsification process is to transfer the crisp numerical value into some linguistic variable, which play a pivotal role in the accuracy and parsimony of the model. Different methods used, for example, commonly maximum membership grade that consider the maximum membership value, which controls overfitting but suffer from underfitting because some membership grade that are close to maximum are eliminated, and holistic, which consider all membership grade not maximum, but it's suffer from overfitting because even very small membership grade are considered, and alpha, which is intermediate by controlling overfitting and underfitting by considering the membership grade that are greater than predefined alpha. Knowledge extraction is the step to identify existing temporal pattern on falsified value. It means that fuzzy logical relation are employed to identify existing relation between existing and previous state in the FTS models. Different types of methods, such as rule models, matrix model, fuzzy relation matrices, statistical technique, weighted rule models, and fuzzy cognitive map, for example, is used to extract knowledge. Those fuzzy logical relation, as you can see, with the same left-hand side, are grouped to generate a group fuzzy logical relation group. This is defined as a rule with the format left-hand side to the right-hand side, where left-hand side depends directly on the order or the lag values, and right-hand side is used to predict the future values. After defining the rule, the knowledge-based model is created, which is used in forecasting process containing falsification, finding active rule, and defalsification. But now, what is defalsification? Based on the defalsification is used to transfer falsified to the crisp numerical data. So based on the literature, defalsification method by Chen used widely according to these steps. Firstly, if the right-hand side has no fuzzy set, the output will be 0. If you have one fuzzy set, the output will be the midpoint of the fuzzy set. And if you have more than one fuzzy set, the output will be the average of the midpoint of this corresponding fuzzy set. However, different methods also introduced in the literature to improve the accuracy, that are the modification of chance, by adding, in which the output is calculated by weighted average of midpoint of the corresponding interval. These weights are assigned according, for example, index number of fuzzy set, number of occurrence, trend weighted recurrence, chronological order, and so on. And recently, Silva proposed probabilistic weighted FTS in the literature by adding weights on left-hand side and right-hand side, which is equipped with point interval and probabilistic defalsification. What is high-order FTS? High-order FTS, as you can see, in addition to partition order, also play a pivotal role in accuracy of the model, which acts like a memory for a system. So in this case, the rule is modified according to this equation, in which, as we discussed, the precedent or left-hand side depends on the order and right-hand side or consequence used for creating or for predicting future values. And it also should define optimally, because when you increase the number of order, the model will be more time-consuming. And also in some time series, for example, seasonal time series, we can reach the accurate model but just by considering the recent lag values. What is fuzzy cognitive maps? Fuzzy cognitive map introduced by Costco in 1986 as a particular family of CM or cognitive map. Cognitive map is based on cause and effect causality. It means that it composed of some number of concepts and the relation about the couple of concepts. These directed sign arrows, that known as the weights, reflects the effect among a couple of concepts. Each node is influenced on the other is cause, and the nodes which is influenced is effect. So, for example, in binary cognitive map, as you can see from the table, the activation state of each concept blind can be inactive or active, and so it is blind to a crisp value 0 and 1. And the relation is represented based on this square weight matrices, and each element belongs to this crisp value -1, 0, and 1. But now, what is fuzzy cognitive maps? As you can see from the figure, it has this the same structure as binary cognitive map, composed of some number of nodes or concepts, and also the relation which is considered or represented by square weight matrices. Each element has sign and values, But in this case, its vagueness value in the range minus 1 and 1. And the activation state of concepts also represented by this activation state vector for all concepts in the range 0 and 1. And F, it represents activation function, which can be bivariant, trivariant, hyperbolic tangent, and sigmoid, which is used commonly in the literature. FCM updating rule, what is this? As you can see from the table, you can see that the activation state of each concept can be updated according to the Cosco transition rules. And it means that based on the repetitive application, the weight matrix is used to transfer current activation state of each concept to the next. So different types of updating rule introduced in the literature by considering self or self-connection or without self-connection and with or without memory. But as you can see in these equations, the activation of each concept is updated just by considering the activation state of other concepts just at time t. So according to this equation, we cannot describe the complex the dynamic of complex complex system. So in order to solve this problem, in the next step, order FCM introduced in the literature by considering the activation state of all concepts with regards to the lag values or order, not just by considering the current state and ignoring the past values. So it is rewritten according to this equation, and in the vector term, you can see that we have weights or activation states not just at time t, at any time with respect to the lag values. And W0 is our bias term. Different types or extension version of FCM also introduced in the literature according to this table. They have different structure and properties. These properties are extracted according to this list on the right side of the table, as it is clear. And also they are used in different domains to deal with different problems such as uncertainty, dynamics, rule-based knowledge representation, dynamic and uncertainty. For example, in 2019, general FCM introduced by covering all the properties and to deal with this problem and in the human decision-making or dynamic system with uncertainty domains. What is difference and similarities between FCM and artificial neural network? FCMs can be expressed as interpretable recurrent neural network based on their interpretability. Accordingly, FCM consists of fuzzy logical element during knowledge engineering phase. So, however, they have similar structure. They function differently because of the knowledge interpretability of FCM, which is a kind of interesting feature which enables FCM to model complex system in real world. It means that in FCM, each node and the relation among the concepts provide an accurate interpretability. But in artificial neural network, the neurons are considered just like a computational unit without reflecting any clear meaning. So, however, artificial neural network performs duty perfectly. They are limited because of the interpretability limitation. Because hidden neuron neither interpretable nor explains how or why this solution is appropriate for the desired problem. But on the other side, we have FCM, in which each node has its meaning with a clear relation with other nodes. So we can say that, or it can be said that, there is a trade-off between interpretability of FCM and approximation ability of ANN. And like other physiological systems, the core element of FCM is learning method. According to that, different types of learning strategies introduced in the literature. For instance, firstly, Hebbian-based, it is unsupervised learning method based on human intervention. It has some advantages and limitations, as you can see in the table. Also, different techniques introduced in this category. You can see from differential Hebbian learning, balanced differential Hebbian learning, and so on. On the other side, we have population-based, which is supervised, based on historical data, not human intervention. It has some advantages such as model concepts with precise value, lower simulation error, functionality improvement, generalization ability, and robustness, but it suffers some limitation such as lower number of process, time to consuming, adjustment of training parameters, availability of historical data, and problem with convergency. Variety of method in the literature proposed in this class of learning, but according to our best knowledge, PSO and GA are used widely in the literature. The other method is hybrid, which incorporates Hebbian-based and population-based method, considering the effectiveness of Hebbian-based and global search capability of population-based algorithm. Limited number of methods introduced, as you can see from the table, and the other techniques that are not included in these triple categories, such as EFCM and other methods, such, for example, based on gradient methods. Time series forecasting using FCM. FCM are applied in many applications, such as, for example, social, political control, medicine, and so on, to solve some problem related to classification, prediction, and decision making. According to some interesting features, as you can see here, qualitative modeling is a perception, high ability to dealing with uncertainty, explainability, flexibility, and so on. So they have also excellent applicability in time series forecasting. They are a kind of weighted FTS, which improved accuracy in comparison to weightless FTS methods. In order to use FCM for time series forecasting, we need to consider some essential consideration, including designing proper FCM structure, calculating FCM parameters or weight matrices, and reconstructing numerical values. So time series forecasting using FCM includes two steps. In the first step, we need to design the appropriate structure, which is, for example, by using granularity or fuzzy seams clustering commonly used in the literature. And secondly, training the weight matrices. So diversity of methods you employed to train FCM in the literature, for example, from population-based to faster techniques, such as ridge regression and least square by considering different map size, different number of orders, or presence of the biased weights or not. Now, in this section, we are going to introduce reservoir computing. Firstly, what is recurrent neural network? As you can see, the structure of recurrent neural network consists of 3 layers: input, internal, and output layer. Each layer consists of some number of neurons that they have connected to each other by weights. And in contrast to feed-forward neural networks, they have feedback weights. As you can see in this equation, the state of each unit in the internal layer is updated or calculated according to this equation by considering input weight, internal, and feedback weight. And the output also is measured according to this equation. Recurrent neural network have a powerful, have a strong ability to simulate complex dynamical system, but the training suffers some limitation, including high computational training cost, local minimum, or vanishing gradient. To attenuate these issues, especially with dealing with some complex problem, a new machine learning strategy is introduced in the literature, which is named reservoir computing, which is focusing on stability and initialization instead of focusing on training algorithm. For instance, equal-state network, liquid state machine, and backpropagation declaration are the most popular RC methods in the literature. Equal-state networks are useful for modeling the complex dynamical system due to some features, including very simple training process, high dimensional projection, high space connectivity on neuron, or short-term memory, and our focus here is on equal-state network as a reservoir computing approach. What is equal-state network? As you can see from this figure, the structure is the same as traditional recurrent neural networks, consists of input, reservoir, and output layer. But in this case, the reservoir is not trainable, and just the output layer is trainable, which is a kind of outstanding feature of equal-state network. So the training is a kind of supervised learning method composed of 2 steps. Firstly, the input are mapped to a high-dimensional reservoir, which to calculate or reach equal-state. And in the second step, a simple regression method is exploited to train output. So we have a high-dimensional, sparsely connected, and untrainable reservoir, which each unit in this case in this reservoir is calculated according to this equation, as you can see here. And the output, which is trainable and linear, is used to calculate the output according to this equation. In order to construct the equal-state network, we need to consider some hyperparameters and initialization, such as the number of neurons inside reservoir, the input scale, spectral radius, and sparsity. The most important parameters is the spectral radius, which is used to calculate or initialize the weights of reservoir according to this equation. So, firstly, the randomized, we have double rand, it represents the randomized weight matrix, in which each element is generated randomly from a uniform distribution over interval -1 and 1. And rho max is the maximum eigenvalue of the randomized weight matrices. The other important feature that should be satisfied or considered to guarantee the stability of a equistate network is equistate property. We have necessary condition and sufficient condition to satisfy this property. Firstly, for necessary condition, the epsilon, spectral radius, should be set smaller than 1, and for the sufficient condition, the largest singular value of reservoir weights should be smaller than 1, as you can see here. The other modification of equistate network are deep equistate network, that they have different structure, reservoir have this different structure in comparison to shallow ESN. It means that the reservoir consists of a stacked hierarchy of sub-reservoir, or it means that the reservoir consists of some number of layers that they are connected to each other by some weight matrices, where the dimension depends on the dimension of each successive layers. So the external input is fed just to the first layer. The output of the first layer is considered as input for the next successive layer. In this case also, the weights inside each reservoir and the weights between each successive layers are generated randomly, and they keep constant during training process, and just the output weight is trainable. In this case also, the equistate property should be satisfied. We have some constraint in traditional or standard deep equistate network. Firstly, input just fed into the first layer, not all sub-reservoir, and there is no relation from the upper layer to the down layer. And also, we don't have any relation from the reservoir at layer I to the reservoir in layer greater than I plus 1. However, this represent the standard deep equistate network. Other modification, for example, here we have deep equistate input to all, that input just fed to all the layers or sub-reservoir. And also we have group ESN that there is no relation among a successive sub-reservoir. Other advances of deep equistate network also introduced in the literature, but we are not going to dive into methods, just introduced briefly here. Firstly, a multiple projection encoding deep equistate network consists of some reservoir and some encoders. The size of encoder is smaller than reservoir, because if we have some reservoir with the same size, we cannot reach the maximum advantage of projection in equistate network. And also it can be helpful to deal with collinearity problem of equistate network. The other one is deep leaf equistate network consists of some stacked RBMs. The output, the feature from the top layer is considered as input for equistate network regression, as you can see here. Also, we have deep 3SN or long short equistate network that can be seen from this figure. Now we are going to dive into our proposed method. As you can see from this figure, the general structure of a time series forecasting unit using quasi-cognitive map has been shown through this figure. Quasi-cognitive map models are considered as a connector to generate fuzzy time series at data or falsified value at time t+1. Then the defuzzification step is exploited to generate the out-predicted value. So the goal of our study is to introduce new univariate time series forecasting models using FCM. Firstly, HFCM-FTS model, and secondly, GR-HFCM model. HFCM-FTS model is a new hybrid forecasting model combining the concept high-order FCM and high-order FCM. And GR-HFCM or group random HFCM model is a group of random HFCM model combining the concepts of FCM and ESN. So in order to understand the concept behind our proposed methods, firstly, we introduce FCM-FTS method, which is a first order version of HFCM-FTS. It means that the order is equal to 1 in this case. So firstly, we need to construct the structure of FCM-FTS method. As you can see in this figure A, the universe of discourse is partitions to generate some overlapping interval named as fuzzy sets. And since we consider the concepts equivalent to the fuzzy sets, so for example, we have here 7 fuzzy sets or 7 concepts. In the next figure, the square weight matrices is generated based on the historical data. After defining the concepts and weight matrices, we can generate the fuzzy cognitive map, as you can see from the figure, consists of some number of concepts and the relation among a couple of concepts from the source to target concept. How we combine FCM and FTS? As you can see, suppose we have these time series. Consider the sample at time t. We calculate the blindness or the activation or membership degree of this sample to each concept, which is represented as FTS, as activation state of all concepts, which is represented by FT. We have the weight matrix at time t, WT times FT, applying the activation function, generate the next value of concepts in the next iteration according to the state transition rule, and after that the defuzzification step is employed to generate the final predicted value. In more detail, the structure of our proposed method consists of training and forecasting. In training, the universe of discourse is partitioned into some predefined concepts, which is defined by user, as, for example, 5, 10, and 20 in our model, by using grid partitioning method and triangular membership function. Then genetic algorithm is used to train the weight matrices according to these initialization parameters. After defining the model in forecasting process, in fuzzification step, the activation state of all concepts is calculated according to this equation, in which the activation degree of the membership degree of the element, which is sample y, is calculated to each concept. Then the activation state of each concept is updated based on this equation, where f is tangent hyperbolic, sigmoid, and ReLU. And finally, in the defuzzification step, the final predicted value is obtained by this equation, in which MPI is the center of each concept. Now, HFCM-FTS methodology. HFCM-FTS follow the same structure as FCM and procedure like FCM-FTS, and they are different from each other just by the number of order. And since in HFCM-FTS model, the order is 2, the genetic algorithm should train 2 weight matrices at time t-1 and t. So the activation step in defuzzification is modified according to this equation by considering the weight matrix and activation state of all concepts at time t-1 and t. So according to this figure, we have samples at time t-1 and t. We calculate the activation states of all concepts. We consider activation transition rule to generate the activation states of concepts in the next iteration. Then we consider the defuzzification is applied to generate the final predicted value. Now, in order to assess the performance accuracy of our model in this case, in this experiment, we consider 8,000 sample of solar radiance from the Sonda project in Brazil. We also consider a sliding window with 2,000 sample, 80% of window for training and 20% for test. Root mean square error is used to evaluate the performance of the HFCM-FTS over test data. Now, we are going to consider the effect of some effective parameters, including the presence of the bias term, influence of the activation function, and different number of concepts on the accuracy of the model. As you can see from the first table, we consider or we use sigmoid activation function. as this deduced from the table, adding bias into the model improved the accuracy significantly in comparison to the model without bias, with any case a number of concepts. However, in this case, the number of parameters increased in comparison to the model without bias. In the next one, we consider or we assess the sensitivity of the model against different types of activation function, including ReLU, sigmoid, and hyperbolic tangent. As the table represents, the model has less sensitive against different types of activation function, but according to the figures, the best performance is obtained by setting ReLU as our activation function. And finally, we compare our proposed method with other recent techniques, including high-order FTS, weighted high-order FTS, and probabilistic weighted FTS. As the table highlights, the accuracy of the model is improved significantly by adding weights into HOFTS methods for any number of concepts. But in comparison to WHFTS and PWFTS, the proposed method is more accurate just when the number of concepts are limited to 5. And when we increase the number of concepts, the accuracy of the model in this case is degraded, in contrast to these methods. One hypothesis in this case is that when we increase the number of concepts, the number of parameters in this case increase significantly, as you can see in this column. So it can affect on the convergence of genetic algorithm in our model. So maybe we need to change the initialization of parameters of genetic algorithm. So, however, the proposed method is more accurate with the lowest number of concepts when we increase, and it also is more readable and interpretable. When we increase the number of concepts, the accuracy of the model is degraded, and also the training will be more time consuming. For instance, suppose that we increase the number of concepts from 30 to 40. In the case of 40, GA should solve a problem with more than 3,000 variables in comparison to 1,860 in the case of 30. And this problem will be more acute when we use this model for predicting multivariate FTS. So finding an alternative for GA is highly recommended. In order to alleviate this problem, in the next step, we introduced another new univariate time series, which is named as Group Random HFCM or GRHFCM. As you can see in this figure, it composes of input, reservoir, and output layer. The reservoir consists of some number of sub-reservoir layer, as you can see, in which input fed into each sub-reservoir independently. They generate their own output, which is considered as input for the final output layer. Then the least square minimization is used to train the output layer to generate the final predicted value. The novelty of this model is that the weight inside each randomized HFCM FTS layer is generated randomly according to the equistate property of equistate network, and they keep constant during training process. Since the reservoir is not trainable and just the output layer is trainable, we can say that from this perspective, it is a kind of equistate network. Now, in order to understand the mechanism of proposed GRHFCM, you can see a simple example in this figure, which composed of two sub-reservoir, random HFCM1, FTS1, and random HFCM FTS2, and also their order is 2. So we have two weights at time t-1 and t. It should be noted that, and it is important that we consider bias also in our method, and just because of the ease of notation, they are limited from this figure. The input fed separately into each sub-reservoir, they generate their output. Then the least square minimization is applied to the final or output layer to solve this simple problem. Consists of some this square coefficients and the output from each sub-reservoir. Then it generates the final predicted value. So the structure is explained clearly in this figure. It composes of training and forecasting. In training, firstly, in partitioning step, the universe of discourse in each sub-reservoir is split into predefined 5, 10, and 20 number of concepts by considering grid partitioning method and triangular membership function. In the next step, the least square coefficients are determined according to the following step. Firstly, the weights of each sub-reservoir are generated randomly according to this equation, which is similar to the reservoir weight initialization of equistate network, in which W rand is randomly generated from uniform distribution over -1 and 1. Rho max is a maximum eigenvalue of randomized weight matrices, and epsilon should be set smaller than, which is 0.5 here, to keep the two conditions. Firstly, keeping or satisfying equistate property in equistate network, as well as keeping the elements of weight matrix in FCM in the range -1 and 1. Then the output of each sub-reservoir is generated according to the forecasting process. And finally, the least square method is applied to train the output layer and generate the optimal coefficient by minimizing the error function. So now we have model. In forecasting process, in the first step, the activation state of all concepts are measured according to this equation, just like the HFCM-FTS method. Then they are updated according to this equation. And since the order is 2, it is rewritten according to this equation. It is important to mention that the bias weights here are initialized like this equation, as you can see in this formula. F is the same as the previous model, and just we added soft plus in this case. The falsification process is the final step that used to generate the output of each sub-reservoir according to this equation, and the final output is estimated by applying least square algorithm. According to this equation, it depends directly on the number of sub-reservoir. For instance, if we have 2 sub-reservoir, the final output is calculated according to this, or based on these equations. Now we are going to evaluate the performance of the defined GRHFCM-FTS. In this case, we consider 2 case studies. Firstly, Sonda, and the next one is Malaysia data. In the Sonda, the samples are the same that we introduced for the HFCM-FTS model. And as you can see in this table, the accuracy of the model is obtained in the term of minimum, average, and maximum RMSE and U according to these equations after 20 independent experiments by considering some effective parameters on the accuracy of the model, such as different types of activation function, different number of concepts, different size of reservoir, and also different number of and also the order is 2. As can be seen from the table, regardless of the types of activation function, for a certain number of concepts, when we increase the number of sub-reservoir, as you can see from the table, the accuracy of the model is improved. However, this error reduction is not continuously. We can say that in general, increasing the number of sub-reservoir improved accuracy in this case study. So, for instance, suppose that we have sigmoid 5 concepts, and the number of sub-reservoir is the best performance in this case is obtained for 20 number of sub-reservoir. For ReLU, the best performance is related to the 40, and for soft plus is 20 and tangent is 30. This trend follows for the model with 10 or 20 number of concepts. It means that increasing the number of sub-reservoir improved accuracy. But in contrast, regardless of the type of activation function, with a certain number of sub-reservoir or size of reservoir, when we increase the number of concepts, for instance, from 10 to 20 or 5 to 10 or 20, the accuracy of the model is degraded. For instance, suppose we have ReLU 10, and the number of sub-reservoir is 20, and we have the same condition, and we just increase the number of concepts from 10 to 20. As you can see, the average RMSE error in this case is increased from 138 to 175. to understand what happened, you can see the sensitivity of the model against different parameters on the accuracy of the model. As you can see, the average RMSE and U, regardless of type of activation function, directly depends on the number of sub-reservoir and indirectly depends on the number of concepts. What does it mean? It means that for a certain number of, for any case of activation function, for a certain number of sub-reservoir, when we increase the number of concepts, the error is increased or the accuracy is decreased. In contrast, for a certain number of concepts, when we increase the number of sub-reservoir from left to right, you can see that the error is decreased or the accuracy is improved. However, in some cases, when the size of the reservoir size is greater or equal to 30 here or here, for instance, then there is a slight difference between the accuracy of the model with 5 and 10 number of concepts. This figure shows the sensitivity of the model against different types of activation function. As you can see, the model has less sensitive against different types of activation function that you can see they are represented with different colors. And also, when we increase the number of concepts, the accuracy of the model is decreased in terms of average U and RMSE. And each box consists of 6 values with respect to the different number of sub-reservoir 2, 5, 10, 20, 30, and 40. The best performance of the model is reached with soft plus, as the table summarizes. With different number of concepts, we have the lowest error in comparison to the model with different types of activation function for different types of number of concepts. However, the best performance in any case is obtained for the lower number of concepts. There is a slight difference between the model with different number of concepts, the different types of activation function with the model with the best performance of the model. And also, it can be considered that the number of parameters just depends on the size of reservoir, not the map size. So now we are going to compare our proposed GRHFCM model with other techniques, such as HFCM for the first. As you can see, GRHFCM is more accurate in comparison to HFCM FTS model with any number of concepts. And also it is much faster because it is designed based on least square, which is not repetitive like genetic algorithm, and it does not depend on the parameters initialization, and also it's used to solve a problem with lower parameters in comparison to HFCM FTS. It means that, as you can see, the number of parameters decrease significantly for any number of concepts in comparison to HFCM FTS method. Also, it is more accurate in comparison to HOFTS, WHOFTS, and PWFTS. However, like HFCM FTS, in this case, when we increase the number of concepts, the accuracy is degraded in comparison to these triple methods. But we can consider and conclude that GRHFCM is superior in comparison to other methods. Now, in the second scenario, we consider Malaysia data includes our electric and low temperature. For instance, we consider 8,760 samples of load and temperature by considering a sliding window with the same data segmentation. We also consider 3 accuracy metric with the same map size and reservoir, and the order is 2. But in this case, we just consider soft plus activation function in this case. So, as can be seen from the table, you can see that like Sonda case study, the best performance after 20 independent experiments is obtained by increasing the number of sub-reservoir with the constant number of concepts. And like Sonda, when for a certain number of sub-reservoir or layers, or when we increase the number of concepts for electric or low data set, the accuracy is decreased. this figure shows this happening more clearly. It means that we have the indirect relation between the accuracy and the number of concepts, and we have a direct relation between the reservoir size and the accuracy. It is very clear for the both data sets and different types of concepts and sub-reservoir. This figure also shows the other representation of the accuracy of the model with respect to the different number of concepts and number of sub-reservoir in the box plot representation. Each box consists of 6 values. When increasing the number of concepts make the model inaccurate than in comparison to the model with less number of concepts. And as this table indicates, the best performance for each data is obtained with 5 and different sizes of reservoir, as you can see here. And finally, we compare our proposed method with other recent techniques in the literature. As can be seen from the table, GRHFCM 1, 2, and 3 represent GRHFCM method with 5, 10, and 20 number of concepts. However, FTS-CNN is more accurate in comparison to our proposed method. Our results are still promising according to a couple of reasons. Firstly, GRHFCM is univariate. It means that we consider just one variable to predict our electric, and also the other is associated with the data segmentation. GRHFCM is based on 80% of the data for training and 20% for testing. However, FTS-CNN is designed based on 90% for training and 10% for testing. In conclusion, we can say that GRHFCM is equipped with fast and non-repetitive learning algorithm, and it is competitive in comparison to other techniques in the literature. In conclusion, we proposed HFCM-FTS method and GRHFCM that both are univariate time series. We consider the accuracy of the method by considering map size, bias, and activation function. However, HFCM-FTS is more accurate in comparison to HO-FTS, WHO-FTS, and PW-FTS when the number of concepts are limited. When we increase the number of concepts, the accuracy is deteriorated, and also the training will be much time consuming. So in order to deal with this problem, in the next step, we propose GRHFCM as a group of random HFCM by merging HFCM and ESN and using least square as our learning method. Instead of map size, bias, and activation, we consider the size of reservoir and the accuracy of the model in this case. It is much accurate and faster than HFCM-FTS for any number of concepts. However, this method provides disadvantages. It is still shallow, and if we want to model dynamic problems, complex dynamical problem, as a future possibility of works, we can extend the model to deep random HFCM methods. Firstly, we have deep random HFCM. It consists of some number of layers that are connected to each other by weight matrices. The input just fed into the first layer, and the output of the first layer is considered as input for the second one, for the next one. After and the final predicted value is associated with, for the obtained results of the final layer. The next one is deep random HFCM input to all, which the input is fed into all sub-reservoir, and the next possibility is least square deep random HFCM input to all, that the output of each sub-reservoir is fed as input to the next layer, and also as input for the output layer, and the least square is used to train the output layer to predict the final predicted value. And finally, for the next 2 years of my PhD program, after some correction, I will go to submit to papers and also review on some review on, for example, projection methods, advance of deep ESN, initialization technique. In 2022, I have a plan to code and implement the method for deep HFCM, and also including high dimensional data set and also multivariate data. And for 2023, I'm going to write my final thesis. from the first method, we extracted solar energy forecasting with fuzzy time series using high-order fuzzy cognitive map, which has been published in Fuzz IEEE 2020. And also we have some journals we are going to publish in the coming months. A review study on time series forecasting using fuzzy cognitive maps, energy forecasting using univariate group random HFCM method, and multivariate time series analyzing and forecasting using deep randomized HFCM as mentioned in this in here. They are most important references that I use in my research. And finally, thank you very much for your attention. Thank you, Minds.
Thank you, Omid. Thank you very much for your presentation. We now proceed to the second step of this qualification exam, in which I invite the committee members to evaluate the work and present their comments and feedback. Okay?
Okay.
So I will consider, if everyone allows me, I will consider from the most experienced invited guest, and so we begin with Professor Fernando Gomide. Fernando?
Yep. Well, just to be sure that I'm not a robot. Nice to see you, Omid. Good afternoon.
Nice to meet you too.
Good to see you, Frederico. Many thanks
nice to see you, Fernando. Thanks for coming. Thanks for accepting this invitation.
My pleasure. Omid, the subject, maybe you could put the first slide with the title of your dissertation. The first slide.
The first slide?
Yep.
Mm-hmm. Let me.
How long have you been in the program? This is your first year or the second year in the PhD program?
I am in the second year.
The second year, okay. What courses did you take in the graduate program? Did you take courses in machine learning, optimization?
Yes, I take computational intelligence, data mining, machine learning. These courses I passed at UFMG, and also neural network and deeper neural network when I was a master's student.
Okay, good. Just to have an idea of your background, I believe you should have engineering, computer science background or mathematics. What is your main background? Undergrad.
Sorry?
Are you graduated in mathematics, engineering?
I graduated from electrical engineering.
Electrical engineering. Okay,
yes.
Good. No, just to understand a little bit of the.
Yes.
And let's say
And my master thesis was about time series forecasting using a Quest network.
Using what?
My master thesis was about time series forecasting using a Quest network.
Okay, let me ask you, let's say, first of all, a general question. Because I'm looking at the title of work, I do not see fuzzy time series. No? It's okay. No? But in your manuscript, as far as I understood, you were supposed to be developing a technique or analyze fuzzy time series. So the first question is the following. What type of time series are you considering in your work?
I used what type? It's a kind of A stationary time series, not a stationary.
Okay, but is a fuzzy time series or just
Yes.
a regular time series?
I use time series. But our method, we use fuzzy time series method to in our model to predict data. We have a time series, for instance. We use solar radiance, or this is a kind of, for example, seasonal time series, or also, for instance, in the second step, we use, for instance, in Malaysia, and also we used fuzzy time series method to predict the future value.
Okay, but time series is a collection of data points, indexed in time and ordered in time. So each data point in your development, it's a data point, it's a fuzzy set. What kind of mathematical object is it? What type of data are you, processing, handling in your approach?
I don't understand your meaning clearly.
Okay, I will repeat. Regular time series, it's a collection of data numbers ordered in time, 1, 2, 5, 3 numbers. No? A fuzzy time series is something similar, but they are not numbers, they are fuzzy sets.
Oh, we use
so the questions are following. What type of data are you considering in your time series modeling in forecasting?
I use numerical time series.
Input is crisp data or fuzzy data? The output is crisp data or fuzzy data?
No, we use crisp data and use falsification, for instance, and the output is crisp data, crisp value.
Okay, so where is the fuzzy time series in your approach?
We use, for instance, can I show you, for instance, in my method, we combine FCM and FTS. Do you know? For instance, here, we have FCM, FTS. So we combine our FCM and FTS. In FTS, we consider high order FTS. It consists of some process or some steps, as I mentioned in my text. And after falsification, for instance, if you here we falsified our crisp data by using grid partitioning and also triangular membership functions. So according to this step, we can falsify our time series, and we can reach our interval in fuzzy time in our interval or fuzzy sets.
Yeah. Okay. This figure you showed us is based. What do you do there? Is basically what every type of fuzzy rule-based system like does. So there is nothing really fuzzy from the point of view of fuzzy time series. Because fuzzy time series, if you look at in your own manuscript, is something different. You do not process, you do not handle it in the way you are showing in this picture. That's the point. Let me ask you this because I was a little bit confused, because in the beginning I thought you were supposed to develop a time series modeling in forecast approach for fuzzy data.
No, because, for example, it's our crisp, for example, time series, okay?
Yeah.
We consider a sample at time t. We can calculate the blindness or membership degree of the sample. So after that, our crisp value is transferred to the fuzzy data, okay? It's fuzzified, which signifies the activation state in term of fuzzy values, okay? Then we use the transition rules according to some methods such as Cosco transition, for example, to generate or update the activation state. So our original time series is in crisp or numerical. Then it, according to the fuzzification, is converted to the fuzzified values.
Okay, but so you are not handling fuzzy data. You are handling crispy data. It's crispy data in, crispy data out. Right?
If you allow me to say,
sure.
Actually, if the input data is crispy, we fuzzify and apply the method, and then defuzzify to obtain a crisp output.
Yes.
But if the input data is fuzzy, the method can also be used. If the series is already fuzzy, a fuzzy time series, it can be used without the fuzzification step.
Well, okay, yeah.
Can I help with
sure.
Gomide? That fuzzy time series sometimes is a misconfusing concept, because there are fuzzy time series as a time series composed of fuzzified values, okay, and there's that set of methods that set of forecasting methods, also called fuzzy time series. So the literature have examples of both terms. One to represent the fuzzified data points of a time series of fuzzified data points, and also the family of methods using fuzzy sets to forecast data. And in this case, we are talking using the same term for data, fuzzified data, and for methods. And I agree with you that sometimes this may be confusing.
I understand that, but the point is that when we read the manuscript, you may look at page 31, just to go straight to the point. What we read in the second paragraph is not exactly what I have seen, in the examples. I understand that, but I thought reading the manuscript, the idea was to process the fuzzy time series. What in the definition it's in page 31. I believe you have the manuscript with you. So give a look on the definition of fuzzy time series, because that was ununderstood. Of course, I see what you mean. But the point is the following. I'm trying to understand what Omid is presenting and within the concept of the manuscript that I read. Maybe it's okay, but but it's not exactly fuzzy time series, the subject. There is no fuzzy data in, there is no fuzzy data out. Just to sum up our discussion over here. This process scheme that Omid shows in slide number 29, this is the regular way to process crispy data using fuzzy systems. This number of fuzzification actually is a misnomer, because this was pretty much used in the beginning of during the 80s, 90s. But people still use that as abuse of language, but this is not really, but it's okay. This is not our fault. It's a matter of historical fault. So, it's just a matter of, because to be honest, I haven't seen anything about fuzzy time series. No problem. Just to, just put it from the manuscript, because you don't need that. Actually, the subject you are considering your thesis is pretty much more close to fuzzy regression. You know, but you know, I haven't seen. That's the point. Let me just. Maybe you could show me quickly the slide number 4, just to be sure if, based on what we are talking about, just to be sure if I am understanding, you know, the background context exactly. For instance, just to let you know, just to see if I'm getting your point, no? The way you know. For instance, what does this summation, this sum, means in this definition of subset A? What does it mean?
Here?
Yeah.
It's not the meaning of the summation that, for example, use we are going, for example, use in regularly. It's just to summarize this equation. It consists of the, for instance, for each, it means that each element belongs to each fuzzy set according to their membership degree. Do you know? For instance, if we have the universe of discourse, we have some, for example, some elements, and each element belongs to each fuzzy set according to their membership degree. And I know that what you are saying, that why you are using this summation. How can I say? It's not the meaning that we use, like for instance, we are calculating on some, for example, crease value or something like that.
Yes, Omid, you know, I agree with you. But what I mean is that this summation here, if you look at the literature, this means union.
Yeah.
And the plus, you see, the A is also union. If you look at the papers, Gadelha made himself very clear. This is a shortcut to the union.
Yes.
And each term for the me and sub A1, this it's a point, it's a singleton. So this is union, because this example is a discrete fuzzy set.
Yes.
So you have to understand this clearly, because otherwise, you know, we mess up, you know. Another thing, you say that in contrast to crisp set, fuzzy set defines partial membership by dividing the universe of discourse, U, into partitions in order to explain certain the crisp values of Y. To be honest with you, I have never seen a definition of a fuzzy set like that, because you do not partition anything. You just assign a membership degree to each member of universal set. There you call it universal of discourse. You don't partition. There is nothing to do with partition. So, you know, just to understand what you know, if we agree, at least conceptually, in the foundations, you know, the fundamental ideas that's behind of the work, because otherwise, you know, you think one thing, and I think that I understood you, but what I understand is something completely different, where you are, you know, attempted to you know, to present to us.
I think it is based, use is based on literature, but now I know that it means that each crisp value can belongs to each fuzzy sets based on uncertainty. It means that it's not just 0 and 1. It means that each crisp value can be belongs to each fuzzy set according to a vagueness value. I know what are you saying. It's that. Yes.
No problem, Omid. It's just, the only thing that I would like to point out is that, because this is basically a basic definition, maybe you should look carefully in the literature, because this is somehow well established by now.
Mm-hmm.
If you do not put it precisely as, because that fuzzy set, it's exact theory, fuzzy set theory. It has exact theory about imprecision. So the mathematical formalism is precise.
Yeah.
So it's better to be, to keep the notation precise, because otherwise you create misunderstanding.
Mm-hmm.
That's the point, no?
Yes.
I do not want to spend that much time, because otherwise it's going to take too long. But maybe I should send the PDF with some of the comments, no? So you can see what's behind what I'm telling you, no? For instance, another point, if you look at the figure 2 of your manuscript, I do not, maybe in your presentation you show something, I think.
My presentation?
Yeah, I'm not seeing your presentation here in the screen. Are you sharing the presentation with us?
Yeah, yes, that's me.
Yeah.
Okay. Here?
Yeah, that's what. Funny, if you look at this figure, there are two falsification processes going on.
Here?
Yeah, you have this falsification process up and the falsification process down.
No, I just they are follow the same pattern. They are uniform. But I just because I don't want to make the model so complicated, and I just showed according to this figure. Just because of that, no, they are not different from each other. They follow the same. They are uniform or the same pattern.
They are the same, Fernando, but the one on the top refers to the training.
Yes.
The one on the bottom refers to the testing.
Forecasting.
Yeah, but look, if you look at the upstream, after the falsification, you have fuzzy data F. You don't have fuzzy data.
Sorry? Yeah.
In the up,
Here?
Yeah. After falsification process, falsified data.
Yeah, you have fuzzy data. Yeah, exactly where your point is. Yeah, you don't have fuzzy data in this box. Do you?
We have linguistic variable. After falsification, we have linguistic variable.
Okay.
Then we use.
What is a linguistic variable?
Here. After partitioning, we have linguistic variable. Then we use falsification to generate a falsified.
Okay, but so the point is the following. Do you have, in that box over there, it's a falsified data F? What? Do you have fuzzy data over there?
Here?
Yep.
Yes, we here.
Do you have fuzzy data there?
Yes, because according to this, we have, for instance, the existing and before values, and according to these values that are obtained here in falsified, then we use knowledge extraction to see the connection among the, for example, left-hand side and right-hand side in our fuzzy logical relation.
Well, again, maybe I'm missing some point, but Based on what I read in the manuscript, based on what I heard during your presentation, I don't see any fuzzy data in that box. Maybe, of course, I'm not developing the procedure. I'm not writing the computer program. I do not know exactly. But based on what I read and based on what I heard from you, I do not see fuzzy data over there. But it's okay. It's up to you
Fernando,
to.
I think it's I think we are having some problem with the names. What he means by fuzzified data is just that we obtain the fuzzy representation of the CRISP data.
Yes.
The membership degrees of the CRISP data to the fuzzy sets that have been defined. But it's not fuzzy data. I think you're talking about fuzzy data in the sense of uncertain data, right?
Okay.
Data that may come from subjective fields, from economics. Is that, am I right in my
well, this sounds better as far as his presentation is concerned, but I would like to suggest to review the manuscript because it does not match what is written in the beginning of the manuscript.
Okay, I understand.
Maybe you could just cut. For instance, you mentioned that what the name of the guy? I forgot. The song that was the first to propose for the day. You do not consider the song approach at all. What you do is just
Actually, we replace the song approach by FCM. So the way the original FTS method used to extract the rules for forecasting and so on, we replace that process by fuzzy cognitive method. So that's the basic idea. But I understand that maybe there's some confusion in the names or meanings. But just trying to clarify what we mean there in this diagram by fuzzified data is that just we have a fuzzy representation of the CRISP data by using the membership values up to the fuzzy sets that have been defined. Just that.
Yeah, this sounds better than but Frederico, this is not what is written in the manuscript.
Okay. Well, we may check this. Okay.
Another point that maybe I am also missing is the following. What is your FCM approach for time series modeling in forecast? Where is your FCM model for this purpose? And what is different from what Bart Koska has done previously?
For for both models, or for example HFCM or FTS?
Yeah, well, I think it is slide 29.
29.
No, this is not the. Okay, I forgot to I think it's 19. The slide number, maybe, no?
19?
Yep, I guess so.
19 is
yeah. How do you formulate your FCM for time series forecasting? I could not see your FCM model for
FCM.
Yeah. Where is it?
For instance, here. This is.
But what is shown in slide 29 is exactly the conventional FCM.
No, but this slide is a summary of the literature.
This is a summary.
Yeah, it is, because that's exactly what it is.
Yeah,
so what's your proposal? I cannot see that.
Yeah, this slide is not talking about the model that we are proposing. It's
Okay, but the question is the following: what is your FCM approach for time series modeling in forecast? What is your model? What are you proposing? What type of FCM are you proposing, suggesting to model time series?
What time? Because your question is very general. I don't know what's your meaning of what type of FCM, because FCM different types. For example, we have, as you can see, we have different types of FCM. I don't know your meaning this or your meaning is different. Is in our method we use the general regular FCM. For instance, consists of node and the relation, as you can see in the slides. We in the first method. The FCM, as you can see here in this slide, the FCM is constructed according to this figure. Mm-hmm. It means that the universe of discourse is partitioned to generate some overlapping interval or fuzzy sets. Okay, and in our method, we consider the concepts equivalent to the fuzzy sets. It means that in here, as I discussed, I mentioned, for instance, we have 7 concepts or 7 fuzzy sets, and these weight matrices are generated based on our historical observation, according to our data. Okay, so we in each time series forecasting using FCM, one of the main important thing is the constructing the structure of FCM. So based on this, we generated we have now concepts and the relation. Now we are going to use learning method to train the weight matrices to minimize our error function or for instance fitness function in genetic algorithm or error function in GRHFCM, but if they have different structure. I don't know. Are you meaning this? Can I?
No, because please, I will speak loudly here. Please correct me if I'm wrong. As far as I understood, what you are suggesting is that instead of to use a random neural network in regular reservoir networks, you replace the neurons for FCMs. Basically, I think this is what you are suggesting, right?
Here for the HFCM FTS model, you are talking about this figure, yeah?
Yeah, you use a collection to FCMs, no? Instead of reservoir neural network. This is, I think, you replace the idea of reservoir by the idea of FCM. This is basically, as far as I understood, this is what you are doing in this work, right?
No, it's not a reservoir here. In FCM FTS model, we don't have reservoir. In this case, we have, it's like a neural network. Do you know? In neural network, we have nodes. It's the kind of nodes in neural network, okay? And also we have weights among the concepts, okay? These nodes in FCM, we need to construct the nodes and weight matrices among a couple of nodes. So in order to construct this, we use a partitioning method, for instance, grid partitioning and triangular membership function in this case to generate our fuzzy sets. Okay, these fuzzy sets represent these nodes. Do you understand? For instance, here we have fuzzy sets, 7 fuzzy sets or 7 concepts. And then we use these weight matrices, as you can see. And according to this structure, we train these weight matrices to minimize the error of fitness function. I don't know you understood I could represent it clearly or not, but it is not related to the neural network. It's a kind of interpretable neural network, but we don't use reservoir, for instance.
I think you don't use reservoir. What I'm telling you that you use a FCM instead of a reservoir. You replace the idea of a reservoir by a FCM.
Professor Gomide.
Yeah, sure.
Can I?
Sure.
Let me see if I correctly understood your question. If you see this FCM FTS, if Omid goes back to that first image where I have a diagram of the first time series, yes, stay here. Yes, this image is enough. You can see that the FCM just replace for traditional fuzzy time series methods. We have, for example, a rule-based engine in the middle as a knowledge representation. In that first model, Omid replaced this rule-based engine for the first cognitive. So we have the output of this method is calculated as a vanilla fuzzy time series method. Okay. Mm-hmm. The output of the fuzzy cognitive map is the fuzzy sets or concepts that are activated, and the fuzzification is made upon these activated concepts. So the proposal of Omid is just to change that internal knowledge representation. The second model, but in this model, the fuzzy cognitive maps, the weights are learned using a genetic algorithm. The second model, we introduce the first ideas of echo-state networks, but because in the second model, the weights of the fuzzy cognitive map are randomized. The second model, and there's also the third model. I don't know if I could explain better. Do you understood the history of the models?
Yeah, I understand. But the point is that I thought that he was suggesting to use the fuzzy FCM instead of echo state network structure. I think
no. Sorry, I am
in the second
talking.
method that Professor.
I am sorry. In the second method, we have just like this structure, okay. Yeah. But instead, these weight matrices are initialized randomly. Do you know? According to
no, I got it. But but that's what I mean, you know. So and you don't have the neural network. You have as a collection. You have your FCM.
Yes.
Then you put the weights random. Then use a sort of a least square to estimate the output. That's what you do.
Yes. In the second method, we have we have different. For instance, say 2, 5, 40 of this structure or this fuzzy cognitive map that they are grouped. Do you know? For instance, we have 2, 5, 20, 40 number of randomized fuzzy cognitive map that they are collect to generate our second method according to the echo-state network concept.
I don't want to take too long, because otherwise my fellows will not have a chance to discuss with you. Yeah, but just the next slide. Let me just This is how your network works. Keep going ahead. Yeah, the next. Yeah. No.
Go ahead.
Keep going. Yeah.
Okay.
Yeah. Well, that. So this is what you're proposing now. This is what Professor Petrônio called the second method.
Yes,
right?
it is. Exactly.
That is what they call the second method, Professor Petrônio. Yeah. Okay. Good. No?
Yes.
So I understand that in Figure 18 that the basic building block in the middle of the picture you call a random HFCM. No? It's a FCM is not a echo state network, right? It's
no.
FCM, no?
No, it's FCM, but
that's exactly what I mean. That's exactly what I'm telling. So you use the least square to compute the y hat, no? The prediction.
They are FCM, but with randomized weights.
No, it's okay. No problem. No? It's a bunch. It's a collection of FCMs. No? Each one producing a gas, a forecast, and then you use a least square to to diversify, so to speak. No? That's the point, right?
Right. The least square regression applied to train this method and generate the numerical predicted value.
Yeah, but the point is the following. Okay, but how do you find the final, no? The final output value, the y hat, no?
The final predicted value, you mean that?
Yeah, in t+1, yeah.
Yeah. Firstly, can I keep going to see better? Yes. Here in this figure shows the structure of our proposed GRHFCM method. Firstly, since here we have our input data which applied or fed to each layer separately. So the universe of discourse here is partitioned in the first step according to the predefined number of concepts or fuzzy set. Okay, by using grid partitioning and triangular membership function that we consider in our method. Then when we are going to present our method, we need to firstly, as you can see from this figure, we have in output layer, we have some least square coefficients. For example, lambda 0, 1, and 2. Okay, so in order to introduce final predicted value in test data, firstly, we need to calculate these optimized coefficients. So the second step is related to define or determining the least square coefficients. How we can do it? No, we initialize weight matrix. Suppose that we initialize our weight matrix according to these values. However, we have bias also, but we didn't show because of the ease of notation, just that. This is, so we have random HFCM, FTS, like our first method. It is like just like as our first method. Now, in order to calculate these values for each sub-reservoir, we consider this forecasting. Because why? Because we have in this case we initialize weight, we can update, and also we have the activation state, which is considered as the membership of each sample to each fuzzy sets. So in this equation, we calculate the activation of each concept, which is updated. So we have these, we replace these elements here in this equation, and also we have the center of each concept then the output of each sub-reservoir is updated. Okay, so we have the output. Now, however, we consider the weight according to this formula by considering the epsilon as 0.5 to consider this condition for ESN and the elements of weight in FCM. After we calculate the output of each sub-reservoir, now in the final, so in this equation, we have these elements, y hat 1 and time t plus 1 and y hat 2 at time t plus 1. So we have some unknown parameters, lambda 0, 1, and 2. According to our error function, we can define the optimum least square in this case. So according to this, we have now lambda, we calculated the least square coefficients. So we have our model. So if we consider the forecasting or new sample data, we can calculate the final predicted value very simply, because we calculate the output of each sub-reservoir, and also we have the least square coefficient from our training process. So we can calculate the final predicted value, just according to this equation, as you can see here, which is a simple linear program by considering the number of sub-reservoir, like this, for example, for 2 number of layers.
Okay, Omid, I think I will stop here, because otherwise my fellows will not have time to, to discuss with you. But before to give the floor back to Frederico, I just would like to make one minor comment. I would suggest a careful review of the manuscript, just to put just to contextualize what we are doing, to put it in the proper context, in the proper background material, because otherwise may confuse the reader. I think you do have a very interesting approach for time series prediction. I think the idea is quite interesting. It's quite it's quite nice. I did enjoy it very much. My only difficulty was to filter what you are actually doing against what you wrote. So there was a mismatch between what I read and between I believe you are doing. Just this could be helpful in the future to polish your manuscript, to help us to understand, to grasp exactly what are you planning to do. Because otherwise, as a reader, because may miss some important points, some stuff. But in general, I think the idea is quite interesting. It's quite. I just got confused because he starts to talk. You repeat in your slide about fuzzy time series, but we don't see that in manuscript. So I think everything it's fine, but I would just suggest this careful review of the manuscript, to put things that you do in order to help us to understand what you are doing. And one final remark: it would be interesting if you could explain to the readers why your approach does work.
This approach?
Why does it work?
GRHFCM, your meaning, yes?
Why does it work in the following sense? What's the justification? Because behind it, there is a modeling power, because you are modeling a dynamic system. So, for instance, we know that echo state networks are approximators, as most of the neural networks. We also know that FCM has some approximation capabilities, depending on how do you look at it. And of course, you can use any kind of algorithm, any kind of procedure for instance, many colleagues in the area, there is a very strong debate between what makes, for instance, what makes the eco-state work, like other similar neural networks. Many people think that the following: you put a bunch of computational elements in the middle layer, in the middle, put up a number of that, just get a bunch of connection, throw it, doing a kind of transformation between, to higher dimensional space, and then you leave to the least square the task of finding the good approximation. So there is a strong debate what is really going on behind the scenes of eco-state network. And another classical, I forgot the right name right now. There is another project developed by Huang in Hong Kong. I forgot the name. It just escaped. It would be interesting if you could, elaborate a little bit to explain why. Basically, the following. The point is the following: what is the modeling power?
Because
exactly, extreme learning machine. Perfect. Thanks, Silva. Exactly. Thanks a lot. Yeah, exactly. Exactly. That's it. But to exploit a little bit the modeling power of your framework, because this is not clear. I think it would be great if you could bring to us this kind of interpretation together with your approach. This is basically what I would like to, to suggest to you. But look, I will give the floor back to Frederico because I do not want to monopolize our discussion here. I think our colleagues certainly have some, interesting comments. Anyway, thanks a lot, Omid. I did enjoy your approach. This is just some kind of academic discussion to improve the manuscript, to help us to understand what we are doing. I did enjoy it very much. Thank you, Frederico, Professor Petrônio, for opportunity to be here today. Wish you lots of luck, and hope you'll be, finish your PhD successfully. All the best to you, Omid. Thank you very much.
Thank you very much for participation. Thank you.
Gomide, thank you very much for your comments and feedback. It's always a pleasure to have you in the committee. Actually, this kind of manuscripts are very challenging because Omid's work involves different fields, different areas like FTS, FCM, and eco-state networks, and it's challenging to put all this together in a way that's not confusing. But we'll pay more attention to that. Thank you very much for your comments. We now move to the next member. I would like to invite Professor Guilherme. Guilherme, the floor is yours.
Thank you very much, Frederico. Can you hear me?
Yes.
Good?
Hi.
Yes, it's very good.
Okay. Good afternoon for everyone in this section, and especially for Mr. Orang.
Good afternoon.
Mr. Orang.
Yes, I can hear you. Welcome.
Thank you and your advisors to invite me to take part in this section, in this evaluation committee for your qualifying exam. Well, I enjoy a lot the topics, all the topics you mentioned in your dissertation. And for me, it was really a pleasure to read the document.
Thank you.
I understood almost everything okay, I have a bias because I was in the evaluation committee of the thesis of Petrônio. And so I know more or less the idea behind your approach, the origins of your approach.
Where all this coming from, right?
Yeah, exactly. So I have some comments, but just a few ones. Okay. As I told you before, I find all the topics involved in your research very interesting. Now, in this case of the dissertation of Mr. Orang, I see that you have concepts from fuzzy theory, evolutionary computation, and neural network, all in a package. So it's quite interesting. The document is very easy to read. There are some, of course, minor errors, for example, in the English, but I think it's
recommendation. Okay.
It's easy to correct them. And I have some questions, but not doubts. You know the difference, right? I need to understand a little bit more, just like Professor Fernando Gomide did before me. It's just to understand a little bit some of the approaches and some of the pathways taken. Let's take a look at page 68. I think it's a minor error. So most of if you could share.
Let me,
of your document, page 68.
Let me jump just a minute.
Okay.
Just a second.
It's equation 3.16. I think just a minor error in this equation.
Let me.
60 what? 62?
68. Equation 3.16.
$68, yes.
Right? Are you there?
Let me.
Because I showed this equation, but I can show you many others because I think there is a kind of small problem of math notation.
Okay.
In what respect? For example, sometimes you represent vectors and matrices in boldface, and sometimes they are in italic.
Here, 68. Okay.
Since I believe that you will use this document in the future for a journal paper for submitting, you have the plan to submit a survey. You just showed us in your future research. So I believe well, for me it's very small. I think.
Yeah, no, I guess you're right, Guilherme.
So there is a boldface A in the middle of some.
Okay.
So no, don't worry. It's a minor. It happens with the better families. No problem. But you can see, for example, in equations, for example, like page, for example, equations, page 95, equations 4.5, and 4.7.
Here, okay.
You see, in these two equations,
yes.
For example, in this equation 4.5,
okay,
you have x and it's the equation of the state. This is the state equation, right? And you see on the left hand side of the equation you have x in boldface, and in the right hand side you have x in two different formats in boldface.
Sorry.
That's a minor. Okay, I can understand it, and in dynamic system modeling, you have lots of equation and state equation and matrices. It will be very nice to have all this well organized in terms of notation, math notation. So, but it's just because I was reading while I was reading your work, in many parts of the text, I faced this kind of problem with notation, but of course it's minor. Here in 4.7, you see lots of them too.
Yeah.
Here, all the X vector are in italic and like a miscolor number in this 4.7.
Okay.
Okay, but I discovered it because I read it and because I was quite interested in your different approaches.
Thanks.
Okay, so don't worry about that.
Okay.
Let's go. Well, I liked a lot table 4 in page 90.
90?
Yeah, this page 4 is quite interesting, this type of table, you know, but I think it's split in 4 pages, because it's too large, right? But it's quite interesting table.
Thanks.
Congratulations for this, because it means that you read a lot of papers and you but of course you could do something that could help in the later in your work. What your approach in what aspect your approach improves on this previous works. It was not really clear to me until I arrived at the late, the very final of your document. Now I understand.
Yeah. I agree. It's very good, this kind of table. It synthesizes everything.
Yeah, it's wonderful.
And contrasts the different papers.
Yeah, including your approach, your own approach.
Yeah.
You could add a kind of another row here.
Okay.
Maybe not here because you don't talk. You didn't talk already about about the. But just to emphasize or to highlight the contributions of the work.
Okay.
At some point later in the document.
Mm-hmm.
And let me see math notation. About the experiments, I have some. So you have some nice results, or at least potentially good results, right? But I have 2 questions about all the training and testing and validation procedure. Right? We are talking here in your work about one step ahead prediction, right?
Yeah.
There is no recursive use of the prediction. There is no error propagation in an approach, right?
No, because we are just using for one step ahead.
Yeah, okay. Now that's nice, but not really a but. I mean, I'm quite interested in all the works I've been advising or on this topic of time series prediction. I've tried to do some, how can I say, recursive prediction, in some sense, to feed the prediction back to the input and see how the error is propagated throughout as time passes. I've seen a lot of this kind of work in neural networks, for example, neural network community, but in the fuzzy community, I didn't see. I don't know. I haven't seen many approaches to this kind of prediction, this recursive prediction. Do you agree with me? I think we are talking here just as fellows. I'm not questioning your work or your choices about on one step ahead. I just want to listen to other people working in this field of fuzzy time series prediction. My question is extendable to Fred or to Petrônio, for example. Have you seen some works on the treatment of this of the uncertainty?
If I may,
of course.
If I may add something to this. Yeah. I agree with you. It's very important to consider multi-step ahead forecasting. I would say that it's in our radar. But,
okay.
We are planning towards the end of the thesis to consider this. But at this point in the qualifying exam,
so you, Petrônio, all the group, you have this background on fuzzy time series prediction, and even you can start even with a very simple, very basic FCM, FTS, and see what happens, because lots of uncertainty may rise.
As you remember in Petrônio,
and then if you are using fuzzy sets, if you are using fuzzy theory, I think it's a nice mathematical tool to address this uncertainty that increases over time when you try to do recursive prediction. You try to make recursive prediction. I've never seen such a treatment to uncertainty in the prediction in papers. I've never seen. Have you seen something like that?
I guess Petrônio has something to say on this.
So say it. Yeah, of course. I remember this.
My thesis is exactly about this. And
which steps? I remember that we talked a little bit about this, but yes, I think you had both, right? One step and multi-step.
Multi-step, because one of the troubles, one of the key drawbacks we found in all these methods. I mean, first time series. I mean, first cognitive maps. I mean, neural nets, recurrent neural networks. None of them were much concerned about multi-step ahead forecasting, but not only multi-step ahead forecasting. Multi-step ahead forecasting with some measurement of the uncertainty, of the increasing uncertainty of this multi-step ahead forecasting. So this was one of the concerns of my research, and one of the concerns that we want to include in the next methods, in the continuation of this research of the Omid.
Yes.
Yeah, sure, but it's a point that you are your group of research.
I think that
you are on the forefront. You are on the forefront of this topic. So yes, you can create a framework that you can address this kind of problem. You can be the first one, for example. You must be ambitious in some sense, in the sense of you can even create a new field. Why not? You are the expert on this type of thing. Be ambitious in some sense. You are producing very nice papers. I've been following your track in this area. So probably exactly these difficult things are probably some seeds, for example, to create research on, or to not to create, but to start or to motivate people in other parts of the world to look differently for this problem, because I have some applications, for example, that in control systems, for example, you have predictive control. For predictive control, you have to predict the output for multi steps ahead, k steps ahead, for example, and then you act. The controller acts for predictively, in some sense, based on these predictions of the behavior of the system. The system can be a robot, can be can be some industrial plant, something like that.
Exactly.
And I believe that there is plenty of room to do some contributions in this field, especially in this fuzzy time series approach that you are working for now for some time, and to explore this the consequences of recursive prediction.
Okay.
It's just we are exactly on the qualifying exam, so I can I have my role here is to see if you are in the good path. Of course you are, but perhaps give some suggestions of directions to take. Perhaps this one is a good one to take, and this is motivated by the quality of your work and the quality of the publications in the group, all this kind of thing. And I have another technical question on how training and testing and validation. You are working with time series, right? And time series is a collection of ordered, let me say, univariate time series, a collection of ordered samples, let me say. And how do you execute training and testing? I understood that it's holdout, right? You train with the beginning of with the first part of the time series, and then you test with the second part. Or you do something more elaborated, like, for example, scaffold cross-validation for time series.
No,
I didn't get it. How training and testing are executed.
I use the sliding window. As you saw the slides, I use the sliding window. We have, for example, 8,000 samples. We consider 2,000 samples for a sliding window, and go after that. We shift the window, for example, as I remember, by 500, we shift the window. For example, for the first, we have 0 until 2,000. We consider for each window 80% for test training and 20% for test. Then we shift, for example, as I remember, it was 500 samples. Then we consider the 80% for training and testing, and so on until the end of the whole data set.
So it's different of how I understood initially the training procedure. So you are doing cross-validation, right? So
it's a kind of
cross-validation.
Time-based cross-validation.
Yeah, time-based cross-validation. Okay, you do it only once. You don't do it repeatedly, because
each window is an experiment, and then we shift this window. We have another experiment, another test error estimation, and then we take the average.
And then at the end, you have the average of the.
Yes.
The average.
Okay, but
all the windows, all the experiments.
But you do it. You follow the time series only once. You don't do it again and again, and then after 100 of how we call it, independent repetitions. Because
we could have done this because the FCMs are randomized.
Exactly. That's my point.
The result would
That's my point. And then you could have some measure of the sensitivity of the method to random initialization.
That's right. I see your point. It makes sense.
Yeah. But okay,
So
it's
for
not
each-
wrong.
for
The
each
methodology is
window, we
correct.
could have-
Yeah, I know. I understand.
We
This
have
is
a number of experiments for each window, and then
Mhm.
shift.
Yeah, sure. But for me, it was not very clear in the text. But do you agree with me? Because I didn't get this information from the text.
Mhm.
But anyway, now I understood how you performed, and that's it. That's it. I know that because your experiment was kind of very complete in some sense that you tested for different numbers of concepts, FCM concepts. You tested, for example, different numbers of the sub-reservoirs. I know it's very complicated to do it for repeated experiments, independent experiments. Very hard to do that for this kind of.
Yes.
But well, I think that the work is in a good way, in a good path to success. I hope so in the future. And congratulations for what you have done so far. And thank you again for inviting me to be part of this qualifying exam.
Thank you very much for your good suggestion. Okay, I will consider that.
Okay, Guilherme, thank you very much. I took notes here. I'm sure Omid took some notes as well. Thanks for your comments, and your microphone is on.
I will send you a kind of summary of my comments. I have this done.
Perfect. But and also I agree with you. It's a nice suggestion of yours to maybe develop some general approach for multi-step ahead forecasting with machine learning based models that might consider uncertainty propagation. It's
something like this. This is a good name: uncertainty propagation, something like that.
So we are good at
of course. Somebody will do that in the future, perhaps in the near future.
Yeah.
You'd be why not you and your group, your students, Petrônio, and this kind of. Why not you? So I can say, oh, these guys are my friends. I can say that. You know? I'll be very proud of it.
No, it's our pleasure to have you here. Okay, so next is Professor Rodrigo.
Okay. Well, thank you for inviting me. Omid, Frederico, Professor Frederico, Professor Petrônio. I can see that Omid did a lot of work, lots of methods, lots of very complex methods, very interesting stuff. But I have some comments. I'm going to start with the text. Omid, your text has a lot of English problems, okay? They are minor, but they are too many. And it bothered me a little bit when reading the text. So you will have to find a way to fix that for your thesis. Give a chapter to each lab mate you have. Give a page to each lab mate. I know you have lots of lab mates, but it has way too many errors at this point, okay?
Okay.
Regarding your presentation, I always like to make some comments on the presentation. It had too much text in the slides. It was hard to follow along with you. Perhaps you should be more synthetic on the text, just bullet points with 3 or 4 words maximum, so everybody can read everything you put on your presentation. And I think you spend too much time talking about other people's work. You should focus on your work, right? Because we are here to see what you have done, not what other people have done. Okay?
Mm-hmm.
Now going to the work itself, I wasn't able to understand it very well. First of all, because I think you don't have a very precise problem statement, okay? And I couldn't find your research question. Every scientific work, every research work starts with a research question. And what would you say is your research question? What are you trying to answer with all these methods that you are proposing? What gap in the science, in the knowledge, are you trying to fulfill with your work? What can you tell me about that?
Which method? All the methods, or just, for example, this group random HFCM?
I don't understand what's the research question of your work. What's the motivation? I guess the other profs always also ask something related to that. So I don't understand the motivation.
The motivation is using, firstly, is using fuzzy cognitive map in time series forecasting. Okay, but for the first method, after reviewing some methods.
Okay, for instance, let's start from this. Why fuzzy cognitive maps?
Why fuzzy cognitive map? Because
why do you think that's a good idea?
Because it's a kind of explainable and readable method.
So are fuzzy time series. So why do we need something else?
So can you repeat your question again? I'm sorry.
Fuzzy time series, right? Are also explainable, right? They are very transparent, much more transparent than your method, I think. So why are you proposing something new?
What is new in our proposed method? For example, in my second method, is that I am agree with you that in some cases some methods are more related to the parsimony. Some fuzzy time series are maybe much better than our methods. But as you compare our method with some techniques, such as, for example, neural networks and so on, when we use this method, we can reach the more interpretable systems. For example, for explaining in some dynamic problem, complex problem, when we combine FCM with equistate network, we can train in a kind of simple by a simple learning in comparison to other introduced method in the literature, such as, for instance, by using GA or PSO for training fuzzy cognitive maps. But in FCM we decided to focus on FCM. Firstly, just because of the background that we had on fuzzy time series, and we suppose that we can make some improvement on this. There are some gaps on this knowledge-based methods that we can develop some introduced methods, for instance, by Petrônio, and just we decided to work on fuzzy cognitive maps as a kind of knowledge-based method.
Can I add
sure.
perspectives. This is a very interesting question. Why improve? Why create new methods? But there's something that Omid did not show. This is the qualification, and why we creating so complex models for univariate time series. But because this is not the final object of this research. The final object of this research is multivariate time series, more complex time series. So we are creating more complex model to deal with more complex time series, but we want to make it work first in low dimensional univariate time series, and then after we will employ it in more complex and high dimensional time series.
Do you though? Because if the goal is to use this method in multivariate time series, then you should test it with multivariate time series, right?
Mm-hmm. Yes.
So that's why I think the first thing, it's a scientific method. And that's very important because I expect a PhD student to nail the scientific method, okay? Mm-hmm. So the first thing you have to define is the research question, okay? What's the problem that you are trying to solve? Without that, it's impossible to evaluate your work, right? Mm-hmm. Because now you're telling me that this method's not for the application you showed, it's for another application. Without this research question there, how can I tell if the experiments you performed are right, if they are adequate? It's impossible, right? So right. You need to clearly define where you're trying to go, and that's missing.
Yes, because okay. we were testing that if we could make a good result for univariate, we can extend it for multivariate, multi-step prediction, and some possibilities that we can include in the thesis. So it was just because to.
And do you think you have good results for the univariate case?
If I don't know, it depends on the data, but I think yes, our result is promising because as I compare, for instance, in the last slide with other recent techniques, our method is very close to some recent techniques, such as, for example, FTSCNN that proposed by some students in the lab, in the Mines lab. Since we compare our methods, we can conclude that we can extend, and the result is satisfying.
Is it though? Because, well, let's assume that the hypothesis then is that your method is going to outperform other methods, or at least have comparable performance for the univariate time series. Mm-hmm. Okay, if that's the hypothesis, you have to test your method against the state of the art in lots of different applications of univariate time series, right?
Lots of data. Yes, you mean that lots of data set? Yeah.
Different types of time series, okay. Right?
Mm-hmm.
You may even need to try artificial time series to see how the performance varies over different distributions of points, right? Mm-hmm. And you only tested in 2 time series, if I'm correct, right?
3. So, 2, yes, but 3, yeah, 2, 3, okay.
So I think even for the univariate case, you don't have strong evidence that your method is promising, right? With only 3 cases, well, at least, well, you are the specialist. I don't know how how representative these time series are or not, but I think in the universe of all the of all univariate time series, I think the sample is too small. Okay, so that's why it's important to formalize your hypothesis, because that's the only way to design a good experiment. Okay.
Okay.
Because then, if it's for the univariate case, you have to test it on lots of at least a representative set of univariate time series. Okay.
Okay.
So I think you need to define these things clearly, and then you're going to be able to design better experiments. Then you propose to use the reservoir computing. Why? Why do you think that's a good idea?
Because as I understood, the first concepts originated from the simple learning of acquisitive network and initialization of weight matrices, and we consider this to reduce the cost of training computation in comparison to GA. And as I reviewed the literature, the most recent techniques are based on some least square training method, for instance, ridge regression, and recently a paper published focusing on least square. However, we didn't know this after we focused. This paper published according to this square. So, based on just because of solving the high computational genetic algorithm, when we increase the number of concepts, we conclude that it can be a good idea, and also this acquisitive network, the acquisitive network used in many applications to explain complex dynamic system. So, according to this excellent feature of acquisitive network, we decided that maybe we can choose good results if we consider these concepts in our model.
Okay. I have another issue with your experience, because you're comparing. You start by you started by performing experiments to find the best parameters, the best hyperparameters for your method, right? And then you compare your method against the other methods in the same time series. So don't you think you are overfitting a little bit?
Yes, good question. I think that you are talking about this table, yes?
Yes, yeah.
Yes, it is a question that occupied our mind. I think that it is related to, yes, overfitting in our model, because the results are obtained based on our test data, okay? So maybe when we increase the number of concepts, the model will be overfitted. So when we increase the number of concepts, the accuracy is degraded. I don't know. Is it your question? Is related?
Yeah.
Yes.
But also, that and also the parameter setting being done in the same problem that you're gonna test.
Here?
Right? Yeah. You do the parameter setting, then you using a time series, then you test your method in the same time series. That can cause overfitting. So just be careful with that.
Okay.
When designing your experiments. I expect from a PhD thesis a theoretical contribution to the field. Do you see a theoretical contribution in 2 years?
Yes, I think that. Can you explain which aspects? What do you mean about theoretical? Yes, I think we use different machine learning theory. For example, here, combining, for example, in the future we are going to combine deep learning, or, for instance, some machine learning techniques, and I think we combine some.
Do you think your work will generate a contribution to the theory of time series or machine learning? What do you think it's going to happen? Just speculation for now.
I think we would extend our method as a good methodology that we can work on in different subjects. For instance, we can, as I said, we can extend for deep learning using different projection techniques. Also, we can use some initialization technique on our methods to improve the accuracy, or also, as the other professor told, we can extend our model for multi-step. I think we have a good approach on our hand.
Right. I just want you to be careful to not just keep trying a lot of stuff randomly and start from a hypothesis. Consider what has been done toward that problem and find the cracks and the gaps in the knowledge and in the methodologies, and try to fulfill these gaps. Don't just try stuff at random, okay? Be careful with that.
Okay, thank you.
So I'm gonna just wrap up my comments. So basically, what I missed the most was a well-defined problem statement. And I'm gonna give you a homework. Go to the Wikipedia and read the page on the scientific method and understand each step, because I think that's gonna help you a lot. When these things are well-defined, your work is easier because you know what the goal is, and you know what experiments. It's easier to design your experiments. So understanding the scientific method steps will make your job much easier. Okay? And keep in mind that you should have, by the end of your PhD, some a contribution to the theory in the field that you're working on, right? I think that's important for a PhD.
Okay.
So try to achieve that. Okay?
Okay.
I'm gonna send you my text I'm gonna send you the PDF with some comments and other minor stuff, but I'm gonna stop here. Thank you again for the invitation, Professor Fred, Professor Petrônio. I give back the word.
Thank you for your feedback. Thanks.
Thank you, Rodrigo. Thank you for your comments and feedback. We now move to next evaluator, Professor Hugo Siqueira.
I'm here. So, good afternoon officially for everyone. I start saying thank you to Professor Frederico Gadelha, Professor Petrônio, and Omid for the invitation. It's a really pleasure to be here and to see good colleagues like my dear friend, Professor Guilherme Barreto, and my professor from my alma mater, Professor Fernando Gomide. So I'm really honored to be here today. And I start saying that I like very much the work, Omid. I believe you worked a lot, almost 200 pages for a qualification exam. It's a lot of work, and you really worked on your text, and you read a lot of stuff, I believe, to the amount of pages you put in here. I started saying that I like very much your work. For us, the people like us who work in time series forecasting, especially who like X-state networks, it's very good to see new contributions in the field. And so, discussing about the work, I'm just gonna say something. I will very much agree with my dear friend, Professor Guilherme Barreto. How can I say? Something in my life I always is looking for is something to discuss multi-step ahead forecasting. Please go on with this subject. Most part of the works, the researchers just say, I'm gonna use recursive approach or the direct approach, but no one discuss why or each one is the best option depending on the time series you are working on. So I believe this is a very hot topic, and the field of time series forecasting need this kind of discussion. Okay, so as the last one, I believe I am older than Rodrigo, but I appreciate to be the last because the last is always easy.
I'm sorry, I made it.
No, don't worry. It's always easy to be the last one because most of the things I wrote in here, it's discussed before, and I will try to do not repeat everything my dear friends spoke before me. And but just small comments about structure and text is very small discussions, and like my friends, I will send to you my observations in a PDF in here after this contest. Okay. Let me see about just small things about text. I will say you start with a sentence. FTS methods have been employed in various studies as a powerful tool to perform the task of time forecasting in many applications. See, there is no information here. It's too generic. I am using this for a problem in the world that many people work on. It's too generic. Avoid this kind of structure when you are working on a scientific document. Okay.
Okay.
We have a problem here, in my opinion. FCM. What is FCM? Fuzzy cognitive maps or fuzzy C-means for clustering? Both. You must decide which one you're going to use for. I believe it's not good enough to you. I understand in the scientific field, we use the same acronym for both, but in your work, you must I don't know how, but fuzzy something means. I'm not sure, but you really have to do this because it's easy to be confused for a reader. Okay. And other thing about text, and I am in the abstract yet. Forecasting application do the outstanding features. Be careful with this very strong statement. Outstanding, wonderful. Don't use this kind of structure or this kind of word because it's very strong and it's difficult to be sure about all the field all the knowledge about our field. Okay. And again, in abstract yet, many parts you put the acronym before define with this kind of, with that letters means, you know. Please define the full name of the method, and then after do you use the acronym, okay? And okay. Okay. There is a good point in here. When I read in the abstract yet, consistent input layer, reservoir, and output layer. You know, most part of the people who work in artificial neural networks field have no idea what is a reservoir. Just the people who work with X-state network, you know? You could say a hidden layer between something reservoir, you know? And the dynamic reservoir, the full name is dynamic reservoir, not just reservoir. You know, I believe it's important. I am thinking about my students. I will say to my students, please read the work from Omid. And what is it? I have no idea what is it. Professor, what is happening with the hidden layer of this neural network? Okay, I believe it's good to define properly the definitions you are using in your work. So keep going. Let's see. In introduction, Omid, I believe it's missing a lot of not information, but a lot of references, you know. For example, the first paragraph, you mention a lot of strong statements without any reference, you know. It's important to mention, of course, you are doing something unprecedented in your work, but see, in the past decades, back please, first page. Yeah, there. The first paragraph, there is no references, zero, you know? And I believe you are doing something good, unprecedented, but most of you are saying there, it's not from you. Okay. Other people discuss these topics, okay?
Understood, okay.
Let's see. So again, you mentioned PSO, but you didn't define what is the PSO, particle swarm optimization.
Oh, I mentioned here, okay, particle swarm optimization.
Yes, but 24, I'm sorry, my mistake. I'm gonna delete this comment. So again, last sentence. Moreover, the number of legs depending on the type of time series and should be considered. This is not absolutely true, Omid. The number of legs does not depend on the type of time series, but each time series can use different legs when you are working on your predicability or you are doing forecasting. You cannot. Maybe you are using the same type of forecast, the same type of series. I don't know. One I like very much. Streamflow series forecasting. Streamflow from rivers. You know. Maybe this is the same type. If I take the series from different rivers, the same type, but it's different series. You know. And the legs I will use to perform the forecasting probably or certainly is different, you know? So I would say series from same nature can request distinct set of legs and not the type of time series, you know? I believe it's more well defined if you say that. And in the same way, you say types of artificial neural network. I prefer you say architecture than types, you know?
Okay.
Let's see. And I have an idea, but why did you, I am in 1.12 expected contributions. I know you have to choose some optimization algorithm, but there is some special reason to use the GA, or I have to choose you another one. I just take the first one and the most and something like that.
No, we didn't have any special reason, but according to my best knowledge, as I review some literature, GA and PSO used widely in the literature. So we could use, for instance, GA, PSO, or other learning. But GA and PSO are so common and simple. So we decided to use geometric algorithm for our learning method in our research study.
No, there is no problem here. Of course, I will suggest at least you try PSO2, and if you have time for this, but you have 2 years. I would say I would like to say that I'm impressive. You are just 1.5 years in the road to at least 200 pages. A lot of work, my friend. You like to work.
No.
And I congratulate you for this. But if you have time, I believe someone is going to ask you why GA when you're going to publish your papers, you know. And if you try at least PSO, I believe it's good. Please, Professor.
No, it's good that we can push him to go even further.
Yeah, I agree. And another possibility is of course, it's also an easy method. It's the differential evolution. It's easy to apply, and sometimes the literature is showing that they can reach best solutions than the GA and even the PSO. Okay, so it's just a suggestion if you have time to try to. Okay.
Because we sorry.
Please keep going.
We concluded that using population-based method like GA or PSO is not a good solution for our method, because when we increase the number of concepts, the parameters are increased. So it is because of that the next method is focused on, for example, some simple learning methods such as least squares. Because of that, we left it and didn't use any other population-based method.
Mm-hmm. I agree with you, and but I believe you can perform a master's degree for another student, of course, just discussing the best optimization algorithm for your method, you know, for your forecasting method. You know, there is at least 100 population-based optimization methods in the literature. Of course, we are not going to use everyone, but we have ABC, we have ACO, PSO, as we mentioned, Firefly. There is a lot. So there is a ocean of possibilities in here, okay? And sometimes someone could try to do this, because if you do not this investigation, a Chinese will do, you know.
No, they did. Not just using this certain time series, but they in the literature there are some studies that use different types of, for example, population base, and they compare them with each other. For example, using differential evolution, GA, PSO, and ABC, and they compare the results with each other. So there exists in the literature, and as I checked, they did. And however, according to my knowledge.
Okay. No, I agree with you. Mm-hmm. So the same for the first paragraph in the chapter 2. No references in the first paragraph, and very strong statements here. You know, we need the basis, you know, the references to say, no, this is true because the science said. It's not just Omid saying this, you know, it's important. Let's see. Okay. So in page 30, 2.1, first time series, second paragraph, you said, a non-stationary time series can be transformed into a stationary one by a simple differentiation. Depends on the series. Actually, this kind of transformation is adequate to use in series with a trend. But seasonal series, yes, exactly that. Seasonal series, you must use a different kind of transformation, like z-score, padronization, or deseasonalization, you know? And not all non-stationary time series can be transformed in stationary just using differentiation. This is a mathematical treatment. Of course, it's important to use, but it depends on the kind of behavior or statistical behavior your series presents, you know? And I put this comment in here, but this is not really 100% of the times true. Okay?
Okay.
Okay. You can't use, many of the models can't be used, for example, Sarima from the Box and Jenks family, okay? You can't work on it without, if the series is non-stationary. So it's a very important statement, okay? I will say the same, Professor Guilherme said before me, please use the IEEE convention about vectors and matrices, you know, about the bold and the italics. I marked in here, and it's much easier to understand when you use this kind of highlighting in the letters, you know.
Okay.
Okay, let me see. Fuzzy semins. There is something I would like to discuss with you. First time I saw this, I understand you took this information from the literature about the backpropagation neural networks. There is no backpropagation neural network. This is the multi-layer perception. I see later in a table you said this, but if I use the Levenberg-Marquardt training process, this is a LM neural network. There is no make any sense, you know. Backpropagation is the training process, but it's not a feed-forward neural network. It's the multi-layer perception. It's very well defined in the literature, especially if we read the book, the Haking's book, you know, Simon Hake's book. Please. I understand where did you took this information, because the literature many times we see this, but it is wrong. Okay, do not use this construction, in my opinion, because backpropagation is a training process, and I can use at least 100 training process, which is different, but the architecture is still the multi-layer perception. You know?
Yeah.
Okay, in the page 37, you said, as a consequence, optimization, clustering, error, time consuming, although using optimization techniques is beneficial to reach the optimum points of split points between two intervals. This is not absolutely true. This is not absolutely true, because we don't have a guarantee that we're gonna find the optimum points when we're working on an optimization process. The only way to know if we are in the optimum point is to evaluate all the points. And if you evaluate all the points, we don't need an optimization process, you know? I will say good points. I would say good points or better points or something like that, but not the optimum points. I understand the optimum is the best one, okay?
Yeah.
In the past times, I discussed with a dear colleague of us, Professor Heitor, from the same university of my university, but from Campus Curitiba, and he said there is just one or multiple optimum points on a function, if they have the same fitness value, of course. But optimum is the best one. Good points it's minimum, a minimum optimum point is just the global optimum. If you have a local optimum, he said it's not a local optimum, it's just a local minima or a local optimum or maximum point, you know? And the optimum is a complicated term, you know? But minimum point, I believe it's better. I said some in many points here. Perfect again. I like the construction. You're gonna see. But another question that's regarding the time series forecasting, not theory, but practice, I would say. Did you decide the legs of the series based on the autocorrelation function or partial autocorrelation function? Because in page 45, you didn't mention other possibilities, because, as you know, the partial autocorrelation function just evaluate linear correlation between the legs, you know, and this is a future, you know, a future. I can use the legs defined by this future, independent on the forecasting model. But for example, you have the mutual information. It's another kind of filter, and you can take nonlinear correlations between the legs, you know, or more expensive techniques like the wrapper. You know, you can use wrapper, but I understand it's very expensive computationally. But it's important to mention at least the other possibilities beyond the autocorrelation function. Okay?
Okay.
Or even you can use genetic algorithms or PSO, the binary versions of these algorithms. But as I said, it's very, very difficult to understand, especially when you're using a expensive model like this one you are proposing with fuzzy systems. Okay, just a mention, please. I didn't like the term conclusion at the end of the chapter. Say something like final remarks or final consideration. I understand conclusion is when you finish the work. You know, here exactly that. You know, but it's just an opinion. You can discuss this with your advisors. Professor Guilherme, I would like to ask you something. You are here. Artificial intelligence or computational intelligence?
Computational intelligence.
Yeah. Therefore, FCM can learn due to their dynamics from an artificial intelligence point of view. I'm sorry. This is never we are not converged to any point, but in my opinion, artificial intelligence, it's different from computational intelligence, Omid. Artificial intelligence, it's Matrix, Skynet, you know. But in here, I understand we are discussing computational intelligence methods. Okay? I promise I am finishing. Okay, this is very important thing. You are mentioning in page 66, there exist other various types of evolutionary algorithms in literature. But somewhere you said, yes, evolutionary algorithms is a class that belongs to biosphere optimization methods, okay? But we are dealing with genetic algorithms, evolutionary differential evolution, and so on. The methods that discuss evolution, that are inspired in the evolution, but PSO, ABC, ACO, this is not evolutionary methods. This is swarm-inspired algorithms, okay? This is very well defined in the literature, okay? So please correct this in your text. And again, I saw a lot of this information when we are reading about optimization, but this is very well defined, okay?
Okay.
Sometimes you did mention the equations in the text. This is important. You have to mention all the equations and the figures in the text. Okay. About fuzz systems, I will not say a word because Professor Gomide is here. Okay. And I like too, table 4. Very good table. Okay, we discussed this. Oh, you said this, you are talking about page 91. You are discussing FNN, but we are discussing MLP, okay? And you say this kind of network structures are insufficient for dealing with temporal information. Again, this is not absolutely true. You can have good forecasting, good predictions using feed-forward neural networks. For example, the extreme learning machines that Professor Gomide spoke before. You know, no free lunch theorem. You have to try. You have to test to know exactly who is which structure is the best for the time series you are dealing with. Okay, and I believe this is not true. I suggest to how can I say to delete this paragraph. You know, but I agree with you that recurrent neural networks have memory which can be important or it can be good to decide to use for time series forecasting once the samples in time series are time dependent. Okay, I agree with you, but it's not absolutely true. Not in all the time series, not in all forecasting tasks, we are going to find this behavior. Okay.
Okay. Yes.
You said again reservoir here after equation 4.2, but you know, it's better define what is the reservoir before discuss this term. Okay. And also after figure 5, you mentioned here some problems with the RNNs, the classical RNNs that use, for example, BPTT, propagation to time. I would say you can mention the potential instability also in the training process. Okay. And again, reservoir computing, it's not a strategy. Reservoir computing is a field. Okay, inside the neural networks architectures. We can say, for example, you mentioned liquid state machines somewhere here, and equistate networks. This is the field, and the architectures is inside here. Okay, but it's not a machine. In my opinion, it's not a strategy. You know, it's a kind of field. You know. Somewhere I believe you mentioned the hidden layer is not trained. Okay, this is important. I will read to you what I write. It's important to mention that there is a balance between simplification in the training process and approximation capability of the RNNs when using reservoir computing. Okay, the training is easier. I agree with you. It's very fast comparing to the traditional RNNs. Okay, but you can limit the power of the network because you are not training the hidden layer. You know, you are not training the weights of the recurrence. You know, so it's important to mention that equistate network is not gonna solve all the problems of the world. Okay, but we have in here something like a balance between effort during the training and achievable performance. You know, I believe it's important to mention that because a reader can read this. Oh, okay, I will never use a classic RNN again in my life because ESN it's the best option in the world. You know, it's important to point advantage and possible disadvantages. Okay. I am right finishing. Okay, I believe you mentioned the equistate propriety here. It's absolutely correct, but maybe you can mention this propriety a little bit earlier in your text, maybe in the previous section, not when are you discussing just the hyperparameters, but when are discussing the equistate network, okay? Because the ESP is the guarantee that the network is gonna work. It's gonna present memory, and maybe you can put this definition a little bit before, And you did mention, I believe, in equation 4.4, this is the Moore-Penrose inverse operation, isn't it? You should mention this. Okay, you just say it's an equation you can use, but I believe it's important to limit and give the credit to those who create the method. Okay, and also I missed. You didn't mention in here the possibilities of reservoir design. There is a lot in the literature. For example, from Jäger. Of course, the more obvious, from Nosturki and Professor Principe, from Boccato, there is many possibilities to design the reservoir. Okay, everyone is a sparse matrix, but it's different how we put the information in that matrix, and I believe this information is missing in here, okay? So it's good, I like your figures. Very much. And you did mention in page 113 about preprocessing stages in your forecasting process. Do you did some preprocessing? But in here, I understand you are saying I use the CRISP neural network, the CRISP time series, and I'm going to insert in my model, and then I will do all the computation I have to do, and then I'm gonna have the output of the network. And how about the preprocessing?
Sorry, which page?
113. This one. Forecasting procedure. Okay. You can say in here, in the next versions of your thesis, you can mention preprocessing steps, Of course, depending on the preprocessing is problem dependent, okay? But I believe it's important at least to mention the necessity, for example, to transform the series into stationary, okay? Or to normalize between -1 and +1. It's mandatory when using hyperbolic tangent as activation function, And maybe this kind of stuff should be discussed here, or at least mention one sentence just to say, okay, it's necessary to step the preprocessing and before to start the forecasting process. Okay? Please.
Okay, no.
And also, when you are discussing the 115, the genetic algorithm, okay, you said to me why you are using the GA, but I believe the link between the GA and your proposal, it's a little shallow, I believe you can do better to explain what the genetic algorithm sessions is doing here. Okay, so as mentioned in page or in section something, the genetic algorithm, the method which is define the parameters, the parameters 1, 2, and 3, we are going to use this method here. Okay, the link, it's like, how can I say, it's something like out of place in here. So, well, I'm discussing forecasting methods and fuzzy methods, and here genetic algorithms. Why?
No. Sorry, can I speak?
I already understand your reason. You know, I am thinking in the readers, not on us. You speak why you are using the genetic algorithm, but the link between the sections. Okay. So I just, as a final remark, I'm just finishing. I just would say it's important. I strongly agree with Professor Rodrigo. It's important to mention why did you choose this time series, okay? Specifically this time series. I understand you are proposing a method. It's a generic method for any kind of time series you have in real world problems. I understand what this is it, okay? But it's important to mention why did you choose this time series you use in this document, and expand for more than 2 time series, especially when you are looking for wanting to write a paper, you know, to write a manuscript in an important journal. Just 2 or 3 time series, a benchmark time series. I mean, I believe you can do. You can explain why you are choosing this time series, and use more than this you using here. Okay, Professor Frederico, I believe I am finishing in here, but I didn't find, as a final remark, a statistical test. Omid mentioned many times, my proposal, my method overcame the most of the other methods I am presenting here, but without a statistical test, we can't affirm this certainly, okay? I suggest the use of the Wilcoxon test, okay? It's very simple. You can find this in Python, MATLAB, where you want. And because we must be sure that the results are different, you know? We must be sure, statistically speaking, okay? So this is the suggestion I have to you. Okay, there is a lot of small things in here, small observations, but I believe this is a very good piece of work. I am very happy to participate, and I agree with my dear colleagues that it's easy to read your text, Omid. Very read. You speak very fast, man, you know, you speak very fast, but it's very easy to understand your English, you know, speaking or writing. So congratulations for you, for your advisors for this work. I am sending to you this document with my observations, and I believe you're going to do very good stuff in here, okay? Thank you
very
again,
much.
Professor Frederico and Professor Petrônio.
Okay, Professor Hugo Siqueira, thank you very much. It's also an opportunity to meet you. It was a pleasure to have you here. Thanks for all the comments, the careful reading of the text. I would like to say just a few comments. First, regarding the statistical results, I agree with you. I totally agree with you that for the papers, the journal papers, and the final thesis, we must include statistical analysis. But at this point of the qualification, we are just showing initial results and trying to make a proof of concept and show promising results of these ideas. But I agree that this should be included. Regarding the pace of speaking of Omid, it was also interesting to me when I saw his first presentation, his rehearsal of the presentation. I was amazed on how fast he could speak. But then I suggested him to reduce the pace a little bit. He was
breathe, man, breathe.
But anyway, thank you very much. Thank you very much for your participation. So before I I make some general comments, I would like to give the floor to Petrônio.
Thanks, Professor Frederico, and thanks again for inviting me to join this research. I would like also to thank the participation of Professor Guilherme Barreto, Professor Fernando Gomide, and Professor Rodrigo. Thank you for joining us today. And well, a lot of things was said about the research. I agree with almost everything, but I have to agree, especially with the some critics of Professor Gomide, because I never used that song and Chisholm notation, because I don't agree with that notation of fuzzy sets, okay? That notation he used in his most famous papers was already discussed and criticized many times, because it was wrong, okay? When I saw that notation in the Omid thesis, I asked myself if I should cut it off or let it as is. And finally, I decided to let it as is. Well, Omid paid for my bad decision, for my omission. And next time I will trust more on my experience. And what I thought, it's not to challenge a notation that widely spread over the literature. I don't know if you saw, I shared with you in the chat a paper published 4 days ago, a paper in the first time series field. And the people still using this bad notation. Then that's why, because that notation is very is widespread, I let the text in the Omid text when I was reviewing. So next time I will cut it off, definitely. So about the history about the models, we are testing a lot of different stuff and checking if they work well together. So we have we are trying many hypotheses, and I have to say that Omid have done a great work. You saw a lot of stuff he researched and wrote, and the code he wrote in the text, the experiments he performed. So it's a lot of work. And we still have a lot of work to do. Okay, it's a good challenge ahead of us, and I'm satisfied. I'm satisfied with what we have now, but that's a lot of things to do. As I said before, we have to investigate the multivariate time series, not only simple multivariate time series, but high dimensional multivariate time series. Also look to many steps ahead forecasting. And there's a lot of things that we can investigate, but as many options we have, there will be many dangers to follow many ways. We have to focus on what will be our our preferred model method. I don't know. So I think that our next challenge, Omid, is to define what will be the main product of your thesis. What will be your principal production, or your principal product? Okay. So this is a challenge now to focus and improve the ideas we have until now, but to focus on one method and make this method the best method for that problem. And as Rodrigo said before, we have to specify very well what is our main problem, and say this method we are proposing is the best method to solve this main problem. So you can give many contributions, propose many methods, but I think we have to decide what will be our main product, our main method, and to solve what main problem. Okay, so this, I believe this is our challenge for these last 2 years. Congrats for your good work. Thank you again, Professor Fred, for the invite to join this research.
My pleasure.
I give back the word for you.
Okay, thanks, Petrônio. If you can turn off your microphone, because I'm okay. Thanks, Petrônio, for your comments. It's my pleasure to have you as co-advisor of Omid. Well, first of all, I would like to thank again all the members of this evaluation committee. It's really a privilege to have such strong researchers and colleagues in the committee. I think one, if we can say, a positive aspect of these remote defenses is that now we have the opportunity, like in this case, to have 4 external members in this committee. All the members of this committee are external to the UFMG, and so it's a great opportunity to have members from all over the country to evaluate this work. The qualifying step, I would say, is the most important step of a PhD. It's an opportunity that we have to stop, think about what we are doing, collect our results, our ideas, and organize them in a meaningful way, and then gather this feedback from peers, and high quality feedback from peers. So I think it's a strong aspect of the qualification exam, and of course, a strong contributes a lot towards a final thesis with good contributions and high relevance. So for all these, I would like to thank the members. I would like to thank again Petrônio for the part. And I would like to congratulate Omid for the work. As many colleagues have said here, in a little bit more than 2 years, Omid did a lot of work, a lot of literature review. So at the same time, he's reviewing works from 3 different fields, fuzzy time series, fuzzy cognitive maps, and reservoir computing, and putting elements from these fields together in a new model, a new hybrid model that could have relevant contributions to the field in terms of replacing, using FCM as a reservoir and bringing some interpretability to this model. So we have a lot of possibilities to discuss in this work, and I'm very excited about these possibilities. So I think you have a strong work on it. We have some results that are promising. Of course, we have to organize them with more experiments so that they can be at a level of publishing in journals. And I would like to say as well that the chapter, your reviewing chapters are very good too. You did a lot of work on this. Your fuzzy cognitive map chapter on time series forecasting, I think it can become a survey paper, a review paper. So we might work on that for possible submission. Well, that's it. I think you have a very good work. You have potential to achieve a strong thesis, very good thesis in 2 years. Okay, Omid.
Thank you very much. Thank you very much for everything. Professor Frederico is the best, and also thank you very much, Petrônio, who is support me every time. And thank you very much for the committee for the good suggestion, and I will try to improve and consider all the consideration that they suggested for me.
Okay, so now we proceed to the third stage of this defense, in which I would ask Fabio to cut us from the broadcast for a while. Just a moment. So the committee will deliberate about the result, and then we come back in a few minutes to announce the result.
Ele já está falando português
Acho que
ou...
He knows, he knows. Okay. So, after some time deliberating and discussing with the members, we decided that Omid is approved in his qualification. Congratulations, Omid.
Congratulations, Omid.
Actually, we decided this very quickly, but we were just chatting and telling cases and stories. But the result was decided right from the beginning.
Now, we also prove a new theorem, no?
Okay, thank you.
So congratulations, Omid. Congratulations for the hard work.
Right. You did a lot of work.
Your mic is off, Omid.
Thank you very much, all the committee members. Thank you for the participation. I hope to do a good thing for my PhD.
Congratulations, and good luck to you. See you soon.
See you. Thanks.
Congratulations for the work. Thank you very much. Thank you for the audience. And that's it.
Thank you very much, and appreciate Petrônio and Frederico also. Thank
No,
you.
you are like a guy. You are in good hands.
Thank you very much.
Thank
you.
you.
Bye-bye.
Bye. See
See
you.
you all.
See you, my friends. Thank you very much for this opportunity. See you.
See you.
See you.
Bye bye.
See you, Frederico.
Pleasure
See you,
to meet you
Petrônio.
guys.
Abraço.
See you.
Bye-bye.
Salve, amigo.